square by r square. Fraction of kinetic energy rotation, that means rotation by total. Okay, no problem, no problem. If you multiply fraction with 100, you will get percentage also. Yeah, and we did 1-2 questions from there. No problem, no problem. Yeah, I will give you one more question. Come on, we'll do some more question, then we will move further. You can write. You can write. You write. When a body rolls, it is found that when a body rolls, it is found that 40% of its kinetic energy, when a body rolls, it is found that 40% of its kinetic energy is rotational. When a body rolls, it is found that 40% of its kinetic energy is rotational. Identify the body. Identify the body. Means you have to tell me which body it is, hollow sphere or solid sphere or ring or disc. When a body rolls, it is found that 40% of its kinetic energy is rotational. Identify the body. For identifying body, always you have to calculate the value of Raman. Very good. Yeah. Whenever anyone asks you to identify the body, you have to calculate the value of k square by r square. If k square by r square comes 1, it will be ring. If it comes 1 by 2, then it will be a disc. If it comes 2 by 3, then it will be hollow sphere. If it comes 2 by 5, then it will be a solid sphere. So whenever anyone asks you to identify the body, always find the value of k square by r square. Yeah. Hanudeep also very good. Lakshmi also very good. Ravi Dhanush, it is wrong. Vanilla wrong. Rutvika wrong. It will not come solid sphere. It will not come solid sphere, Baba. It will come hollow sphere. Bankatesha Teja correct. Yeah. Tulasi wrong. It will come hollow sphere. This is what I am trying to tell. Whenever anyone asks you to identify the body, always calculate value of k square by r square. When you calculate the value of k square by r square, if it comes 2 by 3, it will be hollow sphere. If it comes 2 by 5, then only it will be a solid sphere. Yeah. Here it will come 2 by 3. That means our body will be a hollow sphere. Yeah. Okay, no problem, no problem. So just see here, no problem, no problem. I will give you one more question after this. Just see, okay, okay. And simply say, sir, what is given in the question? No problem. They are saying you, when a body rolls, it is found that 40% of its kinetic energy is rotational. That means percentage of kinetic energy rotational is given. This percentage is given as 40. And I told you how to find percentage of kinetic energy rotational. That will be calculated with the help of kinetic energy rotational by kinetic energy total into 100. That is fraction into 100 will give you percentage of kinetic energy rotational, which is given as 40. Now you have to put the simply value. Now you have to simply put the value with the help of ratio. You already know rotational kinetic energy will come, sir, k square by r square. Total will come, sir, 1 plus k square by r square into 100 will be equal to 40. No problem, no problem. Yeah. Now from here we don't know the value. From here previously in all the question we used to put the value of k square by r square and we used to get the answer. But here problem body is not known. So we cannot get the value of k square by. So we cannot put the value of k square by r square. Means we have to calculate k square by r square. And for different body, what is different? For every different body, different value is of k square by r square. So in order to identify, we have to calculate k square by r square. Now from here you can do simple calculation. Better you can cancel these two. No problem, no problem. This will be going with 2 times, this will be going with 5 times. Yeah. And you can cross multiply. So this will become 5k square by r square will be equal to, this will go that side, 2 into 1 plus k square by r square. Now from here you can calculate k square by r square. Yeah. So this will become 5k square by r square will be equal to 2 plus 2k square by r square. Now you can bring this part here. Now this will become 5 minus 2. So this will become 3k square by r square will be equal to 2. That means k square by r square will be coming as 2 by 3. If k square by r square is 2 by 3, definitely body is hollow sphere. Is it okay? Those who are getting solid sphere, did you realize your mistake? Did you realize your mistake? Those who are getting solid sphere. Some people were saying, sir, I'm getting answer solid sphere. Do one more question. Come on, one last question you can do. Come on. One last question you can do. No problem, no problem. Yeah, okay, no problem. Yeah. This time don't do mistake. You can write. When a body rolls, 50% of its kinetic energy, when a body rolls, 50% of its kinetic energy is translational. When a body rolls, 50% of its kinetic energy is translational. Identify the body. Raymond, very good. Identify the body. When a body rolls, 50% of its kinetic energy is translational. Identify the body. Hanudeep also very good. Again, whenever identification is asked, you have to calculate k square by r square. Value of k square by r square will give you type of the body. Shyam, very good. Here when you are, Likhita, very good. Here when you solve, you will find k square by r square is coming 1. That means body is ring or hollow cylinder. Gautami also very good. Harita, very good. Pawan, very good. I think now everyone got, yeah. Sir, you are saying percentage of kinetic energy translational given, sir, that is given as 50%. No problem. Percentage of kinetic energy translational given 50. And we know how to find percentage of kinetic energy translational. That is kinetic energy translational by kinetic energy total into 100, or you can say fraction into 100. This will be equal to 50. Now translation, you know from ratio it will come 1. Total, you know 1 plus k square by r square into 100 will be equal to 50. Now from here you can cancel, this will be 2. Now you can do cross multiplication. If you do cross multiplication, you will get this side 1 into 2 will remain 2. And that side will become 1 plus k square by r square. So from here when you calculate k square by r square, it will come 1. That means definitely body is either a ring or body is a hollow cylinder. Sometimes in place of ring in the NEET, option will be hollow cylinder. Jonathan, I will show all the slides at the end. You can get the QR code at the end. Is it okay? Can I be 100% sure that everyone will be able to identify the type of body when percentage is given? Kar loge? Bata do bhai, kar loge? Arre bol do bhai. Easy only. We can do very easily. No problem. Yeah. Okay. No problem. Yeah. So this type of questions are asked related. Very good. बहुत बढ़िया. Easy only. Yeah. All these are easy only. You can get. Yeah. Okay. No problem. Yeah. Now we are going to move further and we are going to talk about some questions based on energy conservation in rolling. Some questions, you know, in rolling body will have translational kinetic energy, in rolling body will have rotational kinetic energy. Now some questions are asked based on energy conservation. You can write work done and energy conservation in rolling. 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 These are famous questions given in NCERT. Previously also 2-3 times they have asked. Yeah. Energy conservation and rolling. ध्यान दो, be focused, develop understanding. Simple situation only, not tough, but you have to develop understanding. For example, assume this is a body which is rolling. Tomorrow this body may be a ring, maybe a disc, maybe a hollow sphere, maybe a solid sphere. Someone is saying, sir, this body is rolling. That means its center will be moving with some velocity v. At the same time, body will be also rotating with some angular velocity omega. No problem. Yeah. And right now body will have rolling kinetic energy. Rolling kinetic energy means total kinetic energy, because you know rolling means translation plus rotation. Yeah, so I'll simply say, sir, if this body is rolling, that means this rolling body will have translational kinetic energy also, rotational kinetic energy also, that we call as total kinetic energy, and that we can also write as rolling kinetic energy. And this total kinetic energy, you know already, sir, kinetic energy translation plus kinetic energy rotation. Now we already calculated this total energy in the last class, but again I will calculate, no problem. Yeah, translational kinetic energy you can write. So translational kinetic energy, total kinetic energy means translational plus rotational. Translational we know, sir, half mv square. Rotational we know, sir, half I we also know, sir, mk square. Half I omega square. Omega square will come, sir, v square by r square. Already I told you how to write moment of inertia in the terms of radius of gyration, how to replace omega with the velocity, because we already done in the last class. No problem. Yeah. Now from here I can say, that means, sir, total kinetic energy of the rolling, that we call as rolling kinetic energy. First we talk translational kinetic energy, then we talk rotational kinetic energy. Now we are talking about total kinetic energy of rolling, that we name as rolling kinetic energy. That rolling kinetic energy will become, from here you can take half mv square common. If you take half mv square common, you will get 1 plus k square by r square. This we already know because we calculated in our last class. Ratio we calculated there also, I told you the same thing. Is it okay? Up to this, is it okay? Up to this, is it okay? Up to this, is it okay? एक बार बोल दो भाई. No problem, sir. Same thing you told in the last class, same thing you are repeating. Yeah, but we'll change the type of model. One type of question is asked. No problem. Yeah, that means, sir, if a body is rolling, sir, it will have total kinetic energy half mv square into 1 plus k square by r square. Sir, why 1 plus k square by r square is coming? K square by r square is coming due to rotational motion. 1 is coming due to translational motion. So total kinetic energy of the rolling of the body is becoming half mv square into 1 plus k square by r square. Now ध्यान दो, just here. Yeah, okay, no problem. Yeah, okay. Now assume tomorrow this rolling body, this body was rolling. Tomorrow assume this rolling body suddenly started climbing on a hill. For example, right now this body is rolling na baba. For example, tomorrow this body started going up an hill. As the body will go up, its speed will decrease. If its speed will decrease, its kinetic energy will decrease. Can you tell me where that kinetic energy will go? If this rolling body started going upward, where that kinetic energy will go? It will convert to potential energy, mgh. Yeah. So what will happen? As your rolling body will start going up, its kinetic energy will start converting into potential energy, mgh, and you will find that at the maximum height, its velocity will become 0. That means its entire rolling kinetic energy will become 0. So where that entire rotational kinetic energy will go, where that entire rolling kinetic energy will go, it will convert to potential energy, mg into h max. So always remember, if anyone asks you what is the maximum height body will attain on a hilly surface, on an inclined plane, this is the maximum height you will get. So this entire energy will convert to mg into h max. This is the first type of model which is asked. If body is rolling, it has kinetic energy half mv square into 1 plus k square by r square. And if it will go to some maximum height, their entire kinetic energy will go where? That kinetic energy will not come in your pocket. It will convert to potential energy. And you know for height h, potential energy will be mgh. Bolo, 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 bolo. Done, 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 done. Is it okay? समझ में आया? For yeah, okay, no problem. Frictionless, we don't need to talk. Yeah, Jabir, that's correct. But we are talking about rolling. No problem, no problem. Yeah, okay. Now someone says, okay, sir, we understood. Yeah. As you tell me, tomorrow in place of hilly. Yeah, okay, no problem. So total kinetic energy of rolling is, sir, half mv square into 1 plus k square by r square. Where that energy will go, sir? So it will convert to mg into h max. Because body height is increasing. So kinetic energy will reduce, that kinetic energy will convert into potential energy. Yeah. Now tomorrow assume in place of this hilly area, if your rolling body finds a spring in its path, you tell me if this rolling body finds a spring in its path, then what will happen? Rolling body is not now going on hill. Now rolling body find a spring in its path. Then what rolling body will do? Now what rolling body will do? Bolo bolo bhai jaldi torga. What rolling body will do now? It will compress the spring. When it will compress the spring, its speed will decrease. Its kinetic energy will convert to spring potential energy. So always remember, same energy for height you are writing mgh max na. So same energy for spring will be equal to half k into x square. That is maximum compression square. Spring will be compressed and this entire energy will convert to half k x max square. Is it okay? Is it okay? Is it okay? Same thing I am telling you. So always remember, for spring, same concept you will use kinetic energy of rolling, that is, sir, half mv square into 1 plus k square by r square will be equal to half kx square. Just I am talking about different model which is asked here. Same as we studied in work power energy, but there k square by r square was not present because body was only translating. Here body is rolling, that's why that extra k square by r square is coming. Yeah, Akash, correct. Same thing we studied in work power energy. But there only translation was there, that's why you used to write half mv square will be equal to mgh max, half mv square equal to half kx square. But here both energies are there, that's why half mv square into 1 plus k square by r square. Done. Bolo. Come on, Targa. Bol do bhai, we'll start with questions. One more thing I will tell. You tell me, for example, okay, no problem, yeah, okay. One last thing I will tell you, okay. Work will be done by spring potential energy, no problem, yeah, okay. You tell me, last situation, one more situation. If a body is rolling, this question is given in NCERT also, so just see here, yeah, asked previously in the NEET also, just see. If a body is rolling, if you want that body to stop completely means now you have to stop its translational motion also, you have to stop its rotational motion also. Can you tell me how much of work you have to do? How much of work we have to do to stop a rolling body? Can you tell me? How much of work is required to stop a rolling body? How much of work will be required? same as our kind. If you want to stop a rolling body now, you have to destroy its total kinetic energy. You have to stop its translational motion also. You have to stop its rotation. Stop means complete stop. So sometimes questions are asked, how much of work is required? They will give you a body is rolling on the surface. How much of work is required to stop the body completely? To stop the body means if you want to stop the body, you have to destroy its translational also. You have to destroy rotational also. That means you have to destroy this entire rolling kinetic energy. So always remember, work done to stop will be also same as this rolling kinetic energy. So if anyone asks you how much of work is done to stop a rolling body, that means you have to kill, you have to destroy its rolling kinetic energy. And that rolling kinetic energy, you know, half mv square into 1 plus k square by r square. So these are the three questions which are asked from here. Yeah. If I want to stop a rolling body, I have to destroy its total energy. Is it okay? I'm giving you time of 2 seconds. See all these situations. We'll start with some question. Depending on the body, put the value of k square by r square, you will get the answer. Once completed, you can say done, sir. Last line, whatever the, yeah, okay, no problem, yeah. Whatever the energy body will have, you have to destroy that energy, then only it will stop, na baba. If I have total kinetic energy of 10 joule, if I have total 10 rupees, if you want to make me bigger, how much money you will take from me? If I have 10 rupees in my pocket, you want to make me bigger, how much money you will take from me? Jabir, those are out of NCERT. Why you are talking about them? No problem. You have to take my entire 10 rupees. Then only I will become bigger. Yeah, okay. Same thing we are doing here. To stop means you have to make it bigger. Yeah. Come on, we'll start with one question. Do one question. Come on. You write. You write. You write. Find the maximum height. Find the maximum height attended by a ring. Find the maximum height attended by a ring. Okay, no problem, Gyaneshwar. Okay. Find the maximum height attended by a ring moving with speed v. Okay, no problem, Akasha. Okay. Find the maximum height attended by a ring moving with, find the maximum height attended by a ring rolling with, not moving with, rolling with speed v. Remant has given answer. Very good, Remant. Hanudeep has given answer. Yeah, come on fast. Amrut has given answer. Sam also given answer. I think everyone will get. We already know, sir. If you are talking about maximum height, body is rolling, that entire energy of rolling, that is rolling kinetic energy, sir, which we already know, sir, half m v square into 1 plus k square by r square. This will convert to mg into h max. Now you have to do simple calculation. Now from here you can cancel mm. So this will become half v square 1 plus ring. So for ring k square by r square is 1. So that will be 1 will be equal to g into h max. Now from here these two will get cancelled. H max will be coming as v square by g. Do the next question. Come on, do the next question. Some chinna question I will give you. Come on. So very easily you can find maximum height attended by the body which is rolling on any hilly surface. Yeah, you write I will give you NEET 2013 question. One question came from here. Yeah. Okay. V square by G. You write. When a body, okay, no problem. Yeah. When a body rolls up, when a body rolls up a hill, when a body rolls up a hill with speed v, then maximum height attended by it is found to be, 3v square by 4g. Then maximum height attended by it is found to be 3v square by 4g. Identify the body. You have to tell me which body it is. And I told you, whenever anyone asks you to identify the body, you have to calculate the value of k square by r square. So calculate k square by r square, will be able to identify the body. Remant, very good. Hanudeep, very good. Jonathan, wrong baba. Don't guess it. Solve karo. Calculate k square by r square properly. Rutvika, very good. Shyam, very good. Answer will not come directly, baba. Write first equation. For H max, you know, half mv square into 1 plus k square by r square will be equal to mg into H max. Put the value of H max. From there, calculate k square by r square. Depending on value of k square by r square, will get the value. क्या है baba? This is an easy question. This is an easy question. आसान question है. क्या कर रहे हो? Disk will come. Disk or solid cylinder. In the NEET, when this question came, option was not disk. Option was solid cylinder. So both possibilities are there, because when you solve k square by r square will come 1 by 2. So either it is a disk or solid cylinder, whatever present in option. No problem. Yeah. I will simply say, I already know, sir, for maximum height, we already know, sir. Rolling kinetic energy, sir, half mv square into 1 plus k square by r square will be equal to mg into H max. H max you have given, sir, 3v square by 4g. Now solve from here. Cancel, v square cancel, these 2 and this 4 cancel, this gg also cancel. So from here 1 plus k square by r square will be coming as, here 3 by 2 is left. कितना आसान calculation है. K square by r square will become 3 by 2 minus 1, that is 1 by 2. That means body is either disk or solid cylinder. Is it okay? Is it okay? Is it okay? Bolo bhai, Tora. We'll move further. We'll move towards one more question. You write, in the given figure, find the maximum compression produced in the given figure. Find the maximum compression produced in the spring. Body is given solid sphere. Final question from here. Okay, Srikar, yeah. Find the maximum compression produced in the spring. So first write the formula, then put the values, then only you'll get the answer. First write the equation. Some big answer will come. You can just give me idea. You can just type the options. You can type your answer, no problem. Yeah. Hanudeep, very good. Bahut badhiya Hanudeep, no problem. Yeah. Remant, very good. Manas, very good. 3 answers came back to back. All answers are correct. Because we know the concept, sir. What is big deal? We know the concept. Yeah, very good, very good. Shyam also give an answer. Correct, Shyam. No problem. Kitna आसान है, simple. Sir, body is rolling now. That means it will have total kinetic energy now. That is half mv square into 1 plus k square by r square. And this is solid sphere. So k square by r square will be 2 by 5. And I know, sir, when it will compress the spring, this energy will convert to half k into x square. Now from here, half cancel, and you can simplify. This will become mv square. This will become 7 by 5. And will be equal to kx square. So from here, x you can find. This will come here. That will become under root of 7 mv square by 5k. That means it will become v, you can take out, no problem, under root of 7 m by 5k into v. This is the maximum compression in the spring. Is it okay? Is it okay? Done. हो जाएगा. आगे बढ़े. I'm giving you time of 2 seconds. See all this situation. We'll move towards one more part of rolling. Yeah. One more part of rolling we will talk. Once completed, you can say done, sir. Yeah, Akash, that's correct. Once completed, you can say done, sir. And once I will say done, sir, you start saying done, sir. Opika ledu, no problem, sir. We have to become doctor. Why to have Opika, sir? Till NEET 2024, we will not take any break, sir. We'll study to the best possible manner. Now we'll start with our next part. You can write rolling on inclined plane. Rolling on inclined plane. Rolling on inclined plane. Yeah. Rolling on inclined plane. Rolling on inclined plane. Now see here, no problem. We'll start. Just see here. Yeah, okay, no problem. Yeah. Till now also we studied about rolling. But till now our rolling was happening on horizontal surface. थोड़ा ध्यान देना, be focused, yeah. Till now also we studied about rolling. But till now rolling was happening on horizontal surface. Now we are going to talk about rolling on inclined plane. And what difference will come? On inclined plane, body will have one natural force to slide down due to mg sin theta. Dhyan do, be focused, understand what I am trying to tell. Till now we studied about rolling on horizontal surface, sir. But now we are going to talk about rolling on inclined plane. Sir, what will happen in the inclined plane? Sir, on the horizontal surface, mg was balanced by normal reaction. But on inclined plane, you know now, every body will have a natural tendency to slide down due to mg sin theta. So what will happen when we talk about rolling on inclined plane? We have to also talk about acceleration. Till now you studied about uniform rolling motion where velocity we are taking to be constant. But now we are talking about accelerated rolling motion where body velocity will increase. Acceleration will be there. So understand how the things are going to happen. So just see here how things will happen. Just see. Okay, no problem. Be focused. Just see here. Yeah. Okay. So for example, assume this is one inclined plane. No problem. Don't get worried. Slowly you'll get idea. And finally some formula will come. Those formula you have to finally remember. Ultimately we have to remember some formula. From there our answers will come. But I will give you understanding how to talk about all those results. Yeah. Okay, no problem. Be focused. Develop understanding what I'm trying to tell. No problem. Yeah. Okay. Now assume this is one inclined plane, sir. No problem, sir. This is one inclined plane. Okay, no problem. Yeah. Now, assume on this inclined plane, I'm keeping one body. Tomorrow this body may be a ring, tomorrow this body may be a disc, maybe hollow sphere, maybe solid sphere, any body which can roll, I am keeping on the top of the inclined plane. Top of the inclined plane I am keeping means initial velocity of the body will be 0. I am just releasing the body from the top. So what will happen if you release the body from the top? What will happen? It will roll down. It will roll down means it will come down, and at the same time it will rotate also. At the same time body will translate also and body will rotate also, and then body will come at the bottom. You tell me here velocity of the body is 0. Does here also velocity of the body will be 0? Does here also velocity of the body will be 0? At the top velocity was 0. I have released from rest. Body will roll down the inclined plane. You tell me at the bottom also does velocity will be 0? When it will reach the bottom, then also velocity will be 0. Bolo bhai, bolo. Velocity will not be 0 now. It will gain some velocity now. That means here some acceleration must be present. When body will come from here to here, body must have some. Here initial velocity was sunna baba. When it is reaching bottom, here it has velocity. So someone has. That means someone has increased velocity from 0 to v. That means when body roll down the inclined plane, there will be some acceleration. That acceleration we call as rolling acceleration. Our target is to calculate this rolling acceleration. Our target is to calculate this final velocity v. Jamir, it will come under root of 2gh only when rolling is not happening. In rolling it will not come. Everything we will talk. No problem. Slowly. So first you can draw this diagram, then I will tell you how to get all these values. Nothing to worry. So whenever we release body from the top of the inclined plane, initial velocity will be 0, but when the body will reach at the bottom now, final velocity will be present. If final velocity is present, that means there must be some acceleration. So our target is to find that final velocity. Our target is to find that acceleration. Now dhyan do. Be focused, develop understanding. How things happen. Yeah. Okay, no problem. Just see here. Yeah, okay. Now understand how things will happen. For example, again I am coming back. Assume this is inclined plane. So inclined plane will have height h. Angle of inclination will be theta. Inclined plane will have height h. Angle of inclination will be theta. And let's assume here I have a rolling body. Now what will happen? Actually what will happen? Dhyan dena, be focused, otherwise you will not understand how we are getting the answer. Yeah, okay, no problem. Yeah, I will simply say, sir, what will happen? Once you leave the body at the top of inclined plane, what will happen? Mg of the body will try to bring it down. You know, down the inclined plane, one force will act on the body. That is your mg sine theta. Once you keep the body on the top of inclined plane, mg sine theta will try to bring your body down. Mg sine theta will act down. Mg sine theta will try to bring your body down. So due to mg sine theta, you will get some translational motion. But you tell me, dhyan dena, be focused, just here. Yeah, okay. Achha, tell me, does mg sine theta can give any torque about center? Does mg sine theta will give you any torque about center? Bolo bhai, does mg sine theta will give you torque about center? You know na, in rolling body will also rotate about center. Does mg sine theta will give you torque? No. So if torque is not there, body will not rotate na baba. Dhyan do what I am trying to tell. One thing I will add there. Dhyan do. Always remember, for rolling on inclined plane, friction is mandatory. On horizontal surface, friction there or not there, rolling can always happen. But if you want to do rolling on inclined plane, friction is mandatory, because mg sine theta cannot give you torque. And mg sine theta will only give you force. Body will only translate. But if someone is saying body is rolling, that means rotation must be there. This mg sine theta cannot give you torque. Who will give you rotation? Friction, which will act here. So always remember, for rolling on inclined plane, friction is mandatory. Without friction, rolling cannot happen on inclined plane. Okay, so that's why we will always talk about rough inclined plane. Rolling is happening on rough inclined plane because this friction will be mandatory. On horizontal surface, not mandatory. But on inclined plane, friction will be mandatory. Now, dhyan do. Once you got this, now you can simply say. Now, dekho, yeah. Now, I'll simply say, sir, what will happen? What will happen? Sir, if body is coming down with an acceleration A, I can write net force on the body na mg sin theta down, friction up. So, net force on the body will become mg sin theta minus F. And you know net force on the body will be equal to m into A. This is the equation that we got for its translational motion. Mg sin theta down, friction up. So net downward force, body is coming downward na baba. So net downward force will become mg sin theta minus friction equal to ma. And what is rotational equation? Rotational equation I will write, sir. What will happen, sir? Now this friction will give torque. You can see. Friction will give torque about center. Mg sin theta will not give you any torque. Friction will give torque. So friction will give torque about center. I will simply say that means, sir, rotational equation will come. Torque equal to I alpha. Torque, sir. How much torque will, who will give, sir, torque? Friction will give torque. How much friction will give torque? R perpendicular into F. So I'll simply say, so torque of friction will be equal to I alpha. And what is torque of friction? What is torque of friction? R perpendicular into F. So you can better say R into F. And this will be equal to I alpha. I you can write mk square. And alpha you can write A by R. Because the way you wrote V equal to omega R, we also write A equal to alpha R. So from here alpha we can write A by R. Now from here you can calculate friction. From here you can calculate the value of friction. This friction will become mk square into A by R square. And once you got this friction, you can put this friction here. And once you put this friction here, you will get the value of acceleration. Once I will put friction here, what will happen? You can see. Once I put friction here, this will become mg sin theta minus mk square by r square into A equal to, derivation is little lengthy, no problem, will be equal to ma. Now you can bring this side. So you will get mg sin theta equal to ma, you can take common. Ma will be common. So what is left here? 1. And what is left here? K square by r square. Now from here mm will get cancelled and you will start getting value of rolling acceleration. This we call as rolling acceleration. Rolling acceleration will become g sin theta by 1 plus k square by r square. Many of you remember this result. Now also you have to remember this result. This is the value of rolling acceleration. Ha Jameer Baba, we are studying rolling motion only. So rolling acceleration will be equal to g sin theta by 1 plus k square by r square. And this friction is mandatory. This friction is mandatory. For rolling on inclined plane, this friction is mandatory. Without friction, you cannot get rolling on inclined plane. G sin theta by 1 plus k square by r square. You already know the value of k square by r square. You can put and you can always get the answer. Means finally, ultimately, you have to remember these results. Is it okay? Bol do bhai, thoda, time le do. Is it okay? How we got rolling acceleration? Are bol do bhai. Rolling acceleration will come. This story is not important. Important are few results that will come here. This story I told you just to make you okay. This is how this is coming. It's tough. Derivation is little lengthy. No problem. Yeah. Is it okay? Now, okay, so we got rolling acceleration. We got rolling acceleration, no problem, sir. Rolling acceleration came, sir. Rolling acceleration on the inclined plane, yeah. Yeah, so rolling acceleration we got, sir, g sin theta by 1 plus k square by r square. Rolling acceleration we got g sin theta by, it will only translate, yeah. So rolling acceleration we got, sir, g sin theta by 1 plus k square by r square. Now dhyan do, just see here, yeah, okay. Sometimes question may be asked, to find second target, I told you, na second target is to calculate this final velocity, na baba. I told you, na you have to also calculate this final velocity v. You can find this final velocity v with the help of equation of motion. I already you know initial velocity, na you already know acceleration, na just calculate this distance. This distance you can calculate. If this is h, you can find this distance, na baba, using trigonometry. You can. For calculating velocity, I am just using third equation of motion. First, I will calculate distance, sir. If this distance is L, I can calculate, because I know sine theta will come opposite by hypotenuse. That is h by L. That means L will be coming as, this is the distance which body will move. L will be coming as h by sine theta. And once you got distance, now you can use third equation of motion. Sir, v square minus u square equal to 2a. Rolling acceleration, just now you calculated the acceleration of the body. Acceleration of the body is v square minus u square equal to 2a. A is your g sine theta by 1 plus k square by r square. V square minus u square equal to 2a into s. How much distance you travel? H by sine theta. Now from here, sine theta cancel, and you will get final velocity of the body on reaching ground. On reaching ground, that final velocity will come. That will become square, you can send this side, it will become under root. Sine theta cancel, so 2gh. Under root of 2gh by 1 plus k square by r square. This is the final velocity with which body will reach the ground. Very good. Third equation of motion we are using. If anyone asks you to find the time, you can use second equation. For calculating time, you can use second equation, because you know the distance, na baba. No need to, yeah. Formula you have to remember for all these things. Time you can find, because now you can find. You can use second equation of motion. When body, someone asks me, tell me how much time body will take. So you simply say, I know, sir, S will be equal to U is 0, so half A into T square. S will be how much? How much distance, sir? H by sine theta will be equal to half A. A value you already know. G sine theta by 1 plus K square by R square into T square. So you can find time also with the help of equation of motion. Equation of motion will give you all the values. ये क्या हो गया? Yeah. So with the help of equation of motion you can find. Remembering is easy. In next class I will let you remember. Don't worry. Yeah. I'm just telling you the process. Finally we have to remember only. Finally you cannot derive in the NEET exam. Many places I directly tell the formula and I ask them to remember. But I thought you will try to think how this thing is happening. That's why I told. Is it okay? Bolo bolo bhai torga. Bolo bolo bhai torga. You have to finally remember all these results. And if you put this acceleration, okay, I will do in the next class. There I will do, otherwise you will get confused right now. Yeah. So we got velocity, we got acceleration, and we got how to calculate time. Remaining things, how to calculate friction and how to calculate coefficient of friction, we can talk in the next class. But also I can tell right now also, no problem. If anyone asks you to find friction friction value you calculated here if you put the value of acceleration, you will get friction also. And that friction will come mg sine theta by 1 plus r square by k square. Reverse will come. When you put it here, because here also in numerator k square by r square is there, later on you can put and you can get, no problem, no problem. And if you equate friction to mu n, from there we will get minimum value of mu. All these results I will talk in the next class also. Tan theta by 1 plus r square by k square. These are the value of mu and friction. You can write again, we will talk about these results in the next class. Don't worry. Don't feel it's tough, it's very easy. I have seen all the students doing all the question which is asked from here because they remember the formula. If you see the derivation, it will become tougher. If you remember the formula, it will become easy. Next chapter will be electrostatic, no problem, no problem. That will start next week, yeah. So for today, we'll be ending class here only. More situations from here, we'll be talking next class. Tata, bye-bye, take care. Bye, 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 bye. Homework I send in the group. Homework already sent in the group. Jai Bali. Okay, no problem. Yeah. Again, I will send homework from here in the group. Bye.